Hello and welcome to video 2 on the introduction to using Jamovi. In this video, we're going to talk about how to create a new variable and recode existing variables. We're going to run descriptive statistics. We're going to create a histogram and bar chart. We're going to run a one samples t-test. We're going to run an independent samples t-test, and then run a one-way ANOVA. So I'm going to go ahead and minimize this. I still have the data set we were working on before. So what we're going to do now is we're going to recode corrupt, which is reverse code, so higher scores actually mean less perceived corruption. We're going to change this around and reverse code it into a new variable. So to do that, we're going to go ahead and click on corrupt, then click on the transform icon in this upper ribbon. I'm going to go ahead and call this new variable. It's going to be called corruption2. And then give a description, reverse coded corruption scores. Higher means more corruption. Great. So I'm going to go ahead then, and what we need to do is we need to click on using transformation, click on create new transformation, and this new window is going to pop open. So we're going to go ahead and change this from transform 1 to reverse code. This is useful for using the same type of transformations on multiple variables, which we're not going to do in this one, but it is potentially helpful. So what I do then is we're going to go ahead and then click on the field that says source. Before the $sign, type in 10 minus space source. So what this is going to be is every single instance where we see corruption, it's taking 10 minus each country's corruption score. So a 9 is going to become a 10 is going to become a 0, so it's flipping everything around. And I'll go ahead and click outside of that. And I'm going to click on this arrow down button to close the transformation. Click the arrow up, and we already can see right next to this variable, if I move this space a little bit better, this is our new variable. This is our corruption2. It's already reverse coded it. So 2.5 has become a 7.5. If we add these up together, it should equal the maximum of the range of the measure, which is 10. So this worked out perfectly. So what we're going to do now is we're actually going to go ahead and we're going to create a new variable that's taking our corruption2 and discretizing a variable. So discretizing means we're taking a continuous variable and we're grouping it into essentially like high, medium, and low. This helps with interpretations because rather than talking about a country with a 1.2 versus 1.3, we're talking about low corruption countries versus medium versus high. So it's improved interpretations. Now there is a potential limitation with this because we're treating all the countries within, let's say it's less than 3.34, so between 0 to 3.33, because it is less than 3.34, treat all of them as essentially the same corruption score, so you lose variability. So it really depends on your research question. Now to create a new variable, what we're going to do is we're going to go ahead and click, so we're going to set corruption2. We're going to click on transform, and we're going to change this so it's going to be corrupt underscore catig. I'm going to change this to reverse coded corruption scores categorized. Now I'm going to use a new transformation, and I'm going to click on this add recode condition twice. So what we're going to do now is we have to set our specific bins. So we're saying if source, so again, that source, that's the variable we're transforming. We have to use a logical operator. So I'm going to say if it's less than 3.34, where it says use, I'm going to go ahead and type in single quote, capital, lowercase, low. So saying if it's less than this, we're calling this, and actually we can probably, if you want to, you can spell out low corruption. but for space, just to make it easier to read, I'm just going to say this is low. Now what we're going to do is we're going to say, okay, then it's essentially going to be if source, and you can use some different logical operators here. We're going to say if it's less than 6.67, single quote, medium, and single quote. And that's going to say, okay, if else, then we're going to go ahead and say high. So I'm going to click the arrow down button, and then arrow up. And we can already see it's created the high, the low, and the medium based on this. And if it had missing, it went ahead and carried over that missing. So we went ahead and now we've discretized a continuous variable. So now we're actually going to run a couple of different things. So let's say we had a research question about looking at the mean of a variable. For most questions you might have about your data, you'll want to look at descriptive statistics, then look at graphs, and then run a statistical test. Let's say, for example, you had data from the 1930s indicated the average country had a corruption level of 5 at the time. We will find descriptive statistics for our corruption in our modern sample. We will visualize the data in a histogram, and then we will run a statistical test to determine whether there are statistically significant differences. We hope that this test reveals that the probability of the estimate given the null hypothesis is true is less than 5%. So it's a p-value less than 0.050. Now, p-values do not tell you whether a result is based on random chance or producibility of the result, nor the size of the effect. So what I'm going to do now is we're going to go ahead and get descriptive statistics. We're going to click on the Analysis tab, click on Exploration, and then click on Descriptives. Now what we're going to do then is we're going to go ahead and find our corruption2 variable, and we're going to drag it to our variable list. I'm going to go ahead and move this like so. So you just can slide these panels over. And let's do it this way. So again, I moved corruption2, or reverse code corruption to our variables. And now we have our descriptives. We have our number of responses, how much missing, what our mean is, the median, the minimum, and maximum. Now what we can also do then is we can click on statistics. We can also go ahead and get skewness and kurtosis. So is the potential outliers pulling the mean one way or another? For kurtosis, is it normally distributed? Is it low variability, where it's really peaked? Or is it really high variability, where there's a lot, it was kind of a flat distribution? We're also going to get dispersion, we're going to get standard deviation, and variance. What we do now is we click on plots. We can also go ahead and click on histogram. And that will show you the spread out of the scores. You can also do things like box plots. And the box plot will tell you, okay, what's the distribution? The lower 25 percentile, the middle 50 with the median, and then the upper 25 percentile. I'm going to go ahead and uncheck that. We're going to come back to that later. So note, within our modern sample, our mean is 5.96, which is higher than the 0.5 from the 1930s. Now what we can do then is by clicking here, we can hide those options, and then we're all set with this part. So what we're going to do now is we're going to go ahead and we're also going to look at, in terms of corruption categories. So I'm going to click back on Exploration, Descriptives, and I'm going to go ahead and get essentially just accounts of our corruption category. So I'll put this here. I'm going to check these off and just get a sum. And let's go ahead and take a look at the bar plot. So what I did was went ahead and looked at the counts. For low, how many countries were in low, medium, and high. You can also check this box here too, frequency tables, and that'll give you the percentages here too, which all corresponds to this. I'm going to close out, so I had the options, and there we go. Now let's actually run a t-test to determine if the variable differs from the set value of 5. So I'm going to click on the Analysis tab, click on t-test, and I'm going to choose a one sample t-test. I'm going to go ahead and move our corruption 2 to our dependent variable. I'm going to choose students for the test. The hypothesis, our set value from 1936 is 5. And because I don't have an a priori hypothesis of whether it's going to be lower or higher, I'm just going to select not equal to test value. I'm going to also ask things for mean difference, effect size, confidence interval, descriptives, and you can also do something like descriptive plot, which that's kind of showing all the information there with that. So I'm going to go ahead, it's not really all that useful for this one, but that way we have our student's t-test. So our test statistic, our t is 5.57 with 156 degrees of freedom. Our p-value is less than 0.050, so we reject the null hypothesis that there are no differences between the set value and ours for the sample. Our mean difference is 0.96, and we have a Cohen's d of 0.44, which is our effect size, which is about a moderate effect. Great. I'm going to click over here, and now we can actually, so we'd report all that information, and now we can actually look at it in terms of means from different groups. So we're going to run a independent samples t-test and ANOVA. We're going to look at, are there mean differences of GDPPC for each category? So we'll explore this descriptively, then in a bar chart, and then run a t-test, and then an ANOVA. So the first thing we're going to do is we're going to go back to the Exploration tab under Analysis, Descriptives. I'm going to go ahead and find our corruption categ, and I'm going to move that to split by. I'm going to scroll up, actually I'm going to scroll over here and pull our GDPPC, that's our outcome variable. And that's going to go ahead and report the sample size, how much missingness, what is the mean GDPPC for the low group, the medium group, and the high group. There are some quite large differences there. I'm going to go ahead and get standard deviation. And then I can also go ahead, I can do histograms, which is going to create a histogram for each of the different categories. So as we see here, that's a potential outlier. You might want to run this with and without that case in there. I'm going to uncheck histogram, and let's actually take a look at box plot. So here is the spread outness of our variables too, so we can kind of see what that looks like. What we can also do is I'm going to check bar plots. And this is going to go ahead and provide what is the average for low, medium, and high GDPPC for each of our categories. So looking at this visually, they do seem like there are differences. What we want to do now is we're going to want to compare the means for two and only two groups. We're actually going to compare the low group with the high group. Now what we need to do, because we have 3 levels within our corruption categ variable, we need to go back to our data tab. We want to scroll over to our corruption 2. And what we're going to do is we're going to use a filter. Actually, we're going to go ahead and do a different way of this, a quicker way. So I'm going to scroll over to corruption categ. And let's go ahead and we will click on transform. We're creating a new variable here. We're going to go ahead and call this corrupt categ high versus low. I'll put high versus low corruption categ. I'm going to use a new transformation. And then what we're going to do is we're going to go ahead and for the source, we're going to click on this once. And we're going to say essentially exclamation point equals. So that's saying not equals, single quote, medium, end quote. We're going to say then use is going to be $source, so using the original variable. In the use, we're leaving this empty completely. So we're essentially saying if source is not equal to medium, use the source, else empty. So it's saying omit the medium category. I'm going to go ahead and click outside of this, click on the arrow down, arrow up, and now if we look at our corruption high versus low, we have our highs, we have our lows, but all the mediums are now missing. This is exactly what we want. So what we're going to do now is we're going to go back to our analysis tab. We're going to click on t-test and we're going to do an independent samples t-test. I'm going to scroll over and find our GDPPC variable, find our corruption category high versus low. And now what we're going to do is we're going to add some other features here. Under test, we're going to use students because we use null hypothesis statistical testing. We're going to go ahead and use Welch's, and this is in case we violate the assumption of the equality of variances. So the variability of low should not be statistically significantly different than the variability of high. If it is, we have to use a correction, so we lose degrees of freedom in order to correct for that violation. Since I don't have an a priori hypothesis, I'm just choose not equal to. I'm going to want the mean difference, the effect size, the confidence intervals, descriptives, and descriptive plots. And I want an assumption check for equality of variances. So this is all the data we have. I'm going to go ahead and click this option out and move this over a little bit so we can make sense of this. So I'm going to start in this table here. So a test for equality of variances. The null hypothesis is that there are no statistically significant differences in the variability of the two groups. And here the note says a low p-value suggests a violation of the assumption of equal variances. Our p-value is less than 0.050, so we violated that assumption. So what we would do is, rather than interpret this top row, we'd interpret the Welch's t. So our t statistic is 15.3 with 23.4 degrees of freedom. It is statistically significant, it's less than 0.050, so we reject the null hypothesis. This is our mean difference, upper and lower bound, and we have a huge effect size. This is very large. We also have our group statistics. What's our means, median, standard deviation? And if you scroll down, here's our plots. Notice how there's no overlap in the 95% confidence intervals around those means. So we do have significant differences here. Great. So now what we're going to do is we're going to actually run this as an ANOVA. So that's when you have 3 or more groups. So I'm going to click on Analysis, One-Way ANOVA. I'm going to move our GDPPC to our dependent variable. Corruption category, that's all 3 groups, to our grouping variable. And I'm going to go ahead and choose both of these just in case we violate that assumption. I'm going to ask for descriptives, plots, equality of variances. And then what we also want to do is we want to assess, okay, if there's a difference, because right now we're saying within this, the mean of group 1 equals the mean of group 2 equals the mean of group 3 for the null. If there's any significant differences in any of those relationships, we're going to reject the null. That doesn't tell us where the difference is, though. So we need to run a post hoc test. I'm going to go ahead and click on Games Howl. So actually I'm going to go ahead and look at this first before I click everything else off. And you know what, I'm just going to click on those. The assumption check, so based on this, we violated Levine's again. So we want to use unequal variances, and we want to use the Fishers and the Welch's here. So actually we're going to use Welch's because we violated it. So what we're going to do is we're going to interpret the Welch's. So we have our F statistic, our 2 degrees of freedom. Notice the Welch's, the degrees of freedom is a lot less, but it is still statistically significant. We have descriptive statistics. And with our plots, we have the mean, the 95% constant interval around that mean. Our post hoc test is going to be the comparison from low to medium, low to high. We have our p-values here. The asterisk means it's less than 0.001, so we reject the null. There are mean differences actually in all of these. We can go ahead and click on this arrow to finish. And that is how you would run a one-way analysis of variance. In our next video, we're going to go ahead and talk about scatter plots, correlation, single OLS regression, ordinary least squares regression, multiple regression, and actually how to export all these tables and figures outside of Jamovi.